For this lesson, we're going to be graphing using our x-intercepts and graphing from factored form. Last lesson, we were still using Desmos to graph from factored form, but now we'll be able to find our zeros, find our vertex, and create a graph ourselves. So we're going to start by looking at this example here. And the first thing we're going to do when we're going to graph it, we're going to start by finding the zeros. And in order to find the zeros, I need to write our equation in factored form. So how I do that is I'm just simply going to factor our equation. So I'm going to rewrite it out. First thing we always do is we see if we can common factor anything here. So I look at all my coefficients. I have 2, -16, and 24, and all of those are divisible by 2. So let's common factor out the 2. And now we're just going to factor the stuff in the brackets. So we need two things that add to the middle number and two numbers that multiply to a times c, which is just 12. And if I think about my numbers, that will be -6 and -2. Since my a value inside the brackets is just 1, I can jump straight to my brackets. I don't need to do the full decomposition, but if you would like to do that, you absolutely can. And now I've factored it. And now to find the zeros, we're going to follow our steps from yesterday. So I first set the equation equal to 0. The whole thing is multiplied by 2, so I'm just going to divide out that 2 on either side. So divide out 2, and now we have 0 equals x minus 6, x minus 2, and now we can set both of those brackets equal to 0. So 0 equals x minus 6, so that will give us 6 equals x, and 0 equals x minus 2, so 2 equals x. Sorry, I'm running out of room there. So that is how we find our zeros. So now we have our two zeros. Therefore, the zeros are at 6, 0, and 2, 0. So let's go and put those on our graph. So we have one at 2, 0, and one at 6, 0. Next, we're going to find the x part of the vertex, or our axis of symmetry. So because our parabolas are symmetrical, we know that the x part of our vertex happens right in between our two zeros here. Looking on the graph, I can take a guess that my axis of symmetry is probably going to be sitting around 4, but we'll go through and do it mathematically. So how we find the x of our vertex or axis of symmetry is we take our two zeros, we add them together, and we divide by 2. Similar to how we were doing midpoint way back when. So we'll have 8 divided by 2, which equals 4. So that means that our axis of symmetry is going to be through 4. So that's the first thing it tells us. It also tells us that our vertex is 4 something. So now we need to find that matching y value. So how we do that is we're going to sub in x equals 4 into our equation. And it doesn't matter if you use your original equation or your factored equation. They're the exact same thing, so it really doesn't matter. Sometimes I find subbing into the factored one a little bit quicker, but it really doesn't matter. So instead of writing an x, I'm just going to write a 4. Now we do the brackets first. And then we do the multiplication. So now we can put that y coordinate in our vertex. So that would be our optimal value, or in this case, our minimum. So it's going to be down here at 4, -8. And then I just connect these with a nice curve. Super hard to do it on an iPad, so sorry if it's a little off. So it should look something like that. Now, when we're graphing by hand, we're always doing our best to get it as accurate as possible, but we do know it's not going to necessarily be exactly perfect, so just do the absolute best you can. Okay, so we're going to do another example similar to what we were doing yesterday. So the next one we're going to do is we're going to find the vertex of 2x squared minus 7x minus 30. So the first thing we're going to do is we're going to find the zeros. So how we do that is we start by factoring our equation. So I'm just going to write it out. And now we need to factor this. So we're looking for two numbers that add to our middle number and two numbers that multiply to a times c, which is going to be -60. Now I should have mentioned this first, but we always check if we can common factor first. But here, because 2, -7, and -30, there's nothing that goes into those, we can just move on to the next step. So now we think about our numbers that add to -7 and multiply to -60. So we'll have -12 and 5, -12 and 5. Now we'll go through and we'll do the whole decomposition step. So instead of writing that -7, we're going to use -12x and positive 5x. Now we break that down into our two groups and we common factor out as much as possible. And because my brackets match, that's a really, really good sign. So now we have it factored. The next thing we want to do is we want to find our zeros. So we just set that equal to 0. And we can set both our brackets equal to 0. So our first 0 is at 6, 0. And our second one is at -5/2, 0. So that's the first thing. We found our zeros. The second thing we want to do is we need to find the x of our vertex / our axis of symmetry. So what I'm going to do is I'm going to add my two zeros together and then divide them by 2. So I'm just going to rewrite it a little differently. So we have 6/1 plus -5/2, and I'm just going to write it out like this, and you'll see why in a moment. So let's make some common denominators. We'll have 12/2 minus 5/2, all divided by 2. And that will give us 7/2 divided by 2. Now when we're dividing fractions like this, we're going to flip the second one and multiply. So 7/2 times 1/2, which will equal 7/4. So what that's told us so far is that our vertex is at 7/4 something. So now to find the y value of the vertex, we just sub in 7/4 into our equation. And it doesn't matter which one you sub it into. I'm going to sub it into the original this time, but it doesn't matter. So we have y equals 2 times 7 over 4 squared minus 7 times 7 over 4 minus 30. There we go. Just doing the multiplication. And I'm just going to have to move it up here. So the fractions in this are getting a little challenging, but all the steps are the exact same. So all I'm going to do now is make some common denominators. Oops. And that gives us a y value of negative 289 over 16. So not a very nice number, but we can see how all the steps work again. So that's our final step. But just in general, our steps are find the zeros, find the x of the vertex, and then sub that in to find the y. So no matter what, those are going to be our steps. Okay, let's try another example. So the entryway of the River Point Tower in Chicago is modeled by the relation h equals negative d squared plus 64, where h is the height in meters above the ground and d is the horizontal distance in meters from the center of the arch. How wide and tall is the entryway? So our arch looks something like this. So that's our height, that's our distance, something like that. And if I look here, the way this is written, it's kind of in vertex form. So we can get our vertex from our equation. So it's telling me our vertex is at 0, 64 because it's in vertex form. And now to find these two little endpoints here, we are going to find our zeros. So all we do is we set our equation equal to 0. And now we're going to factor this. So the first thing we always do is common factor. So because I have a negative in front of the d squared, I'm going to common factor that out. Now I need to factor the stuff in the bracket. So this is actually a difference of squares. So we can factor that right away. Like that. And then that negative 1 is multiplied to everything. So we'll divide both sides by negative 1. And we're left with 0 equals d plus 8, d minus 8. And now we just set both of those brackets equal to 0. So we know our zeros are here at negative 8 and here at positive 8. Next, we want to find out what values of d is this relation valid. So because this line here represents our ground, we don't care about any parts of the arch that are underground. So this is only valid for this part. And when I'm talking about valid, I mean in real life. The graph actually will go on forever and ever, but we want to cut it off to the part that makes sense in real life. So the only part that's valid in real life will be from negative 8, which is less than equal to d, which is less than equal to 8. So only in between here. Okay, so we'll do one more together and then I'll have you do one on your own and you can check the answer. So for this one, we're going to factor these and we're going to graph them using the zeros. So this first one here, we have y equals x squared minus 2x minus 8. So the first thing we're going to do is we're going to find the zeros. So we do that by factoring this thing. So we need two numbers that add to -2 and two numbers that multiply to -8. So -4, 2, -4, and 2. Since our a value is 1, we can jump right to the brackets. And then I just set my brackets equal to 0. So that gives me my zeros are at 4, 0, and -2, 0. So let's go and put those on the graph. There we go. Now our next step is to find the x of our vertex, or our axis of symmetry. So what I'm going to do is I add those two together and I divide by 2. So I know that my vertex is looking like 1 and then something, and I need to figure out what goes in the y. So in order to do that, I'm going to find the y of the vertex by subbing in 1 into our equation. And remember, it doesn't matter if I use the factor form or if I use standard form. So that means our vertex is at 1 and -9. So I'll put that in at 1 and -9. And then I'm going to graph it with a nice curve like that. So try the second one on your own and then take a look at the answer.